Okay, now here is our typical stop end that would be used to orient the pre-stressing strands that we would use to apply that compressive force to the beam end. Now note, these strands are not tensioned, they are slack, so there's no danger here. You must be very, very careful with fully tensioned pre-stressing strands, because there's a massive amount of force that can be contained in each of these strands. This particular strand, in fact, we would actually tension up to a load of 209 kilonewtons in just one strand. So what we would do, these strands would be jacked up, they would be pulled back, and they would be essentially stretched. They would be put into that very large amount of tension, 209 kilonewtons for these. The concrete would be cast around the strands into the appropriate cross-section. Once that concrete has reached the specified strength, the specified compressive strength, then the strands would be gradually released, thereby transferring that force that was in the strands when they were stretched into the concrete. So that very large force in the strands would be then applied as compression into the beam itself. Now, notice with this strand layout, there's a far larger number of strands closer to the bottom of the beam. The bottom of the beam, the soffit of the beam would be just 50 mil underneath the actual bottom of the strands, 50 or 60 mil. The reason for that is, not only do we want to apply compression to the beam, we also want to apply a bending moment to the beam as a result of the pre-stressing operation. So because that overall position of the strands is eccentric, it's removed from the centroid of the beam, that enables that application of the pre-stress to also apply a bending moment that will counteract, will act against and relieve the bending moment that results from the applied loads, the loads that will be applied to the beam under working conditions. Let's step back over to the finished beam itself and go through the final steps of the final aspects of how a pre-stressed bridge beam works. Okay, so this beam is one of our finished products. This was actually cast not long ago on this bed itself. Now, you'll notice there's a bit of a gap between the soffit of the beam and the actual bed itself. This is a result of what we just spoke about. When we apply that compressive force from the pre-stressing tendons, pre-stressing strands, not only do they apply that beneficial compressive force to the beam, but they also apply a moment that relieves the moment applied under working conditions. So this moment that's applied by the pre-stressing operation results in the beams actually cambering up. The beam will actually lift up several millimeters, 10 millimeters, whatever the case may be, depending upon the beam and the pre-stressing amount and layout used. It will actually camber up. Now this is beneficial with regard to deflection checks as well too. Generally for bridge beam design we don't need to carry out rigorous deflection checks, but from an aesthetic point of view you don't want a beam visually sagging on site. So this natural camber that results from the pre-stressing operation itself will help eliminate the potential that that beam would be visibly sagging on site as well too. Finally, you'll notice as well too we've got shear links in the beam as well. The shear links we use in the bridge beam would really be not substantially different from what would be you may be accustomed to for reinforced concrete bridge beam design too. So again, so bridge beams, pre-stressed concrete bridge beams would also make provision for shear design, shear reinforcement as well. Okay, so in order to summarize how pre-stressed, precast bridge beams work, beams are intended to carry flexure as well as shear, but that flexure that they're going to carry results in tension in one face of the beam. Concrete is not good in tension. In reinforced concrete, we use bars, steel bars, but in pre-stressed concrete design, we apply compression in order to overcome that tensile stress in the beam due to flexure. The force is applied using pre-stressing strands. The Pre-stressing strands are stretched, concrete is cast around the strands in pre-tension concrete, and the strands are slowly released, thereby applying that compressive force to the beam while simultaneously applying a moment to the beam that also acts to relieve the applied moment. I should also point out as well too that what I've been speaking about here relates to pre-tension, precast, pre-stressed bridge beam design. There is also post-tension bridge beams, which are slightly different, well rather different from pre-tension bridge beam designs.